Now that we've mastered STP and VTP, let's try another exercise with router on a stick, plus all that we've learned so far. This time our VLANs are in order, so VLAN 700 will always take the first 8 interfaces on a switch, 800 will take the second 8, and VLAN 900 will have the third 8 interfaces in each switch. First thing I want to show you is how to add an additional interface module into a router. Fast Ethernet 1/0 is not originally in this model by default. It's mentioned in the exercise guide as well, and this is a mistake. This is R1 instead of R2, but let me show you how to actually do that. You should open the router, stay in the physical card, switch off the router, and add this NM1FETX module. And we already have that module here. To remove it, you can just drag it into the modules list. So we can add that back again. And now we have this additional Fast Ethernet interface. Here it is. I'm going to switch on the router again and close the window. Because I removed the module shortly, this link disappeared, so let me add that again. I'm going to use copper straight through cable. Let's choose Fast Ethernet 1/0 and then Fast Ethernet 0/24 on the switch. So our first task is to set host names according to the diagram, plus rapid PVST on all switches. Let's start from switch 1. Enable configure terminal hostname S1 and then spanning tree mode rapid PVST. That's what I will do on all switches. While we are at it, let's go to router 1 and change the host name there. Our next task is to configure access interfaces and port fast on those access interfaces. I'm going to show you a trick now that I will need Notepad for. We're going to type in all of the commands that we would usually type on a switch. Since all of the interfaces are going to be the same on all switches, we can do it like this. Now follow me. We will assume that we are already in the global configuration mode on every switch. So we're just going to paste this list of commands that we are going to type into this Notepad file right now. On each switch, we will need to enter the interface mode first. So we will say interface range fast Ethernet 0/128, and then those interfaces will always belong to VLAN 700, but we need to say switch port mode access and then switch port access VLAN 700, and then spanning tree port fast. After that, we will go into the next interface range. We're going to say interface range fast Ethernet 0/9 to 16. Switch port mode access, switch port access VLAN 800, and then spanning tree port fast. And then the next range is going to be similar. We just need to change this. I'm going to use 17 to 23 because on these three switches we cannot use fast Ethernet 0/24, and it's going to be VLAN 900 on those interfaces. I'm just going to paste this here. And let's go back up to check if the configuration was successful. So here is our first command. Okay, VLAN 700 created, port fast, and then we have all of these warnings. And then we should get the second range right here. Switch port mode access, VLAN, creating VLAN, port fast, that's fine. And then for VLAN 900, it's here. All of the commands were accepted, so we can move on. I'm going to add exit in the end here, just so that the switch will exit this last range. Switch S5, paste. Same on switch 2. And we are done with our second task. Of course, we can do the same thing with trunk interfaces. I'm going to say interface range gigabit Ethernet 0/122, switch port mode trunk, and then exit. And then we will configure additionally these fast Ethernet interfaces on these three switches. So switch S1, five, let me add another enter here. Maybe that will fix the situation. Okay, so switch 2, we need to make sure we configure the fast Ethernet /24 interface, switch port mode trunk, and then same on switch 6. And then again on switch 7, interface F0/24, switch port mode trunk, and then keep pasting these commands on the last two switches. Okay, Task number 3, done. Task 4 says that we need to configure root switches or root bridges according to the diagram. I hope you remember the simple command to make this happen. So we will look over here and see that switch S2 will be the root bridge for VLAN 700. So switch 2, we're going to say spanning tree VLAN 700 root primary. Switch S7 VLAN 800, and then switch S6 will be the root for VLAN 900. Next task requires us to configure VTP. S7 should be the server. All others are clients. Again, we will use our little notepad hack to configure the clients, but for the server, we will do it manually. So VTP mode server, VTP domain cyber, VTP password cyber. We will create VLANs, VLAN 700, name blue, VLAN 800, name pink, VLAN 900, name green. As for the clients, let's use the notepad. So the commands are VTP mode client, VTP domain cyber, VTP password cyber. The server is S7. I need to make sure to skip that one. Let's go to switch 1, paste. All of the commands were accepted, that's good. S5, paste. S2, paste. Skipping switch 7. And VTP is configured. Next task, configure IP addresses on PCs, DHCP server on the router for all VLANs. Now, I have already, as I promised, done everything that needs to be done on the PC side. I've chosen DHCP, and right now all of our PCs are getting the APIPA IP address, but that will change once we configure the server. But the server will not work until we configure the routing on a stick stuff. So I will actually replace this with this. Sorry about that. So we will do the router on a stick commands first. Let's go to router 1. These are the commands that we need to use. So first we're going to switch on all of the physical interfaces. Then we will create the virtual interfaces, define the VLAN tag that should be expected on those virtual interfaces, and then give those virtual interfaces an IP address, which will be the gateway for each and every computer in that respective VLAN. Enable configure terminal interface F0/0, no shutdown, interface F0/1, no shutdown, interface F1/0, no shutdown. let's create the first virtual interface. It's going to be interface fast Ethernet 0/0. And that's going to be for VLAN 700. So I'm going to say .700. This tells me that this virtual interface has been created and is now up. I will define the encapsulation .1q 700. That is the tag that we are expecting to see on this interface. And then IP address 10.7.0.1/24. Okay, next subinterface, interface F 1/0, okay, 800, encapsulation .1q 800, IP address 10.8.0.1/24. And then the last virtual interface F0/1.900, encapsulation .1q 900, IP address 10.9.0.1/24. That's it for the router on a stick configuration. Now we can move on to DHCP stuff. First, we're going to exclude the first 10 IP addresses that we do not want to be allocated to the clients. So we're going to say IP DHCP excluded addresses 10.7.0.0 for VLAN 700. That's the first one, and the last one is going to be 10.7.0.10. And then I'm going to use the up arrow to change the second octet from 7 to 8. And then I'm going to do the same thing for VLAN 900. And those will be our excluded addresses for all of our pools. I'm going to say IP DHCP pool VLAN 700. I think that is how I named them in the exercise guide. Yep, okay. Network 10.7.0.0 and mask 255.255.255.0. Default router is going to be the IP that we configured on the virtual interface 10.7.0.1. Next pool, IP DHCP pool VLAN 800, network 10.8.0.0/24, and then default router 10.8.0.1, IP DHCP pool VLAN 900, defining the pool, and then the gateway 10.9.0.1. Let's see if the PCs got their IP addresses. Yes, they have. That's great. Now we can test the connectivity. First, we should test the connectivity between PCs in the same VLAN. That's working. And then between PCs and their gateways. And then in the end, between PCs in different VLANs. The ones that are further away might fail due to ARP, but let's try some more. It seems to be working. That's it for this exercise. We can consider it successful. I will update this document and upload it for you to use it. See you in our next lesson.